Hello and welcome to Travel Medicine. As always, I'm your friendly neighborhood internal medicine doc, Dr. J.
Hey guys, Dr. Santhosh here, pediatric infectious disease doc and researcher.
First off, those of you who signed up for the email, thank you. We appreciate it. And I hope you are
Yay!
enjoying your plague, which is a weird thing to
we
say as soon as it came out
yes,
of my mouth, but
we
it is
have
no
emailed
less
a
true.
we have emailed a plague upon you. For those of you who don't know what we're talking about, you're gonna have to listen
So,
as if there's no fast forward
right.
button.
So we sent you a computer plague, not a virus, for signing up.
Yeah. Welcome to all of you folks who are new to the podcast, but one of our favorite segments, Around the World in 80 Plagues, has been made into a beautiful ebook by yours as truly. And it arrived, infectiously in your email inbox.
So that's it. You give us your email and we give you a book. Simple as that, travelmedicinepodcast.com. Which brings me to this week because we already did one of everybody's favorite segments in the ebook, but it's an alternate week, which means it's time for another
Yay!
of everybody's favorite
He's gonna
Journal
say it.
Club.
Yay!
Yay!
Oh, welcome all young and old to the Kermit Arms.
If
Yeah.
you see us at a live show, you may even get to see the puppet version of me do Kermit Arms, which is it's truly a sight.
What everybody out there needs to take from that is that Dr. Josh has a puppet version of himself.
You don't?
I'm sorry. I'm the weird one.
I mean, I wasn't going to call attention to it, but
you're right. You're right. I
it
guess
just
in this
seems
scenario, I'm the weird one.
it seems improbable, impossible, and in line with the strange and unusual nature of our stories this week.
Oh man, segueing it up. I love it.
So we'll start with the one to me that sounds the most sci-fi.
Mm.
Uh, how do you feel about tattoos, Santosh?
I don't yet have one. I've never, kind of gotten up the courage or found out something that like, oh, I'd really like to tattoo. I personally, though, when I see them, I think they're absolutely beautiful. I personally think like the body as a canvas is a gorgeous thing.
So, certainly some people are concerned with having something outwardly on your body, but
Yeah.
if that's the case, no worries because scientists at the University of Texas at Austin and
Okay.
Northwestern University have created a graphene tattoo placed directly onto your heart. This tattoo is doctors already implant pacemakers or defibrillators
Yeah.
in people with arrhythmia.
Yes.
However, these are fairly rigid devices and also run the risk of infections at the leads, clots, or hemorrhaging from blood thinners you may need to be on surrounding the procedure,
Hmm.
bruises, and just damage to soft heart tissues. All of these are acceptable risks, and it's not a reason not to get one if they're recommended.
If it's needed. Yeah. Hmm.
But the fact that there may exist something that could eventually lower that complication rate, as simple as putting a small electrical sensing tattoo over your heart, which is essentially the world's thinnest cardiac implant.
Oh, this is so cool. Now, I guess, well, we definitely have talked about these before, I know, except on the skin, meaning that right now, you go into the hospital right now and they put leads over your chest to monitor your heart while you're in the hospital. Sometimes the pulse ox on the end of your finger and sometimes a temperature probe, but it would be so useful, to get like a temporary tattoo that could do all those things, and not have as bulky and waste and wires and everything else like that. So we know about this concept on skin, but this is actually on the heart, huh? And so yeah, graphene's a conductive material, if I remember properly, and it's, I guess,
It's
one
the
of the most
number 5 pencil.
no that yeah. Essentially, yeah. If you take a graphite, something, if you and you lay it down, and then you put a piece of scotch tape on graphite and you peel it off, you get a single layer like that. Those carbon atoms in the lattice that they're in is called graphene.
So researchers put a piece of a graphene electrode inside a thin silicone wafer and then covered it with gold tape
Hmm.
measuring
Which is
about
inert. Yeah.
10 microns in thickness.
Oh man. So wait, let's remind everybody. So what's a hair? 70 microns. So this is 1/7 the thickness of a human hair.
So you have, and it is applied like a temporary tattoo. So the researchers have already tested this on live mice and rat hearts for a
Oh,
period of 60 days.
okay.
And during the tests, the graphene electronic tattoos, or GETs, GETs,
Yeah. Yay! They named something properly.
successfully achieved cardiac actuation in mice and even treated cardiac arrhythmia in rats.
Oh, that's so good. I love
So,
that.
what is the difference between those two? Do you know?
Mice and rats? Size mostly?
Yeah, I was going to say cardiac actuation and arrhythmia.
Oh, sure. Okay, gotcha. So, actuation, I believe they are referring to the kind of not just rhythmic pumping, but when your heart pumps, it pumps in a very coordinated fashion to squeeze all of the blood in the proper direction. So it can't just be like a round squeeze. It's the action is a little bit like wringing out a towel. It's a very complete squeezing, so the chambers close down as much as they can to push all of the blood in the proper direction, where and the valves direct the flow. But I believe that's actuation, and then arrhythmia, of course, is when the heart does not beat in a proper rhythm in order to properly deliver blood.
Yeah, instead of a 1, 2, 3, 4, you get a 1, a 2, an 8, 12, 15.
Just all over the damn place. Yeah, like a crazy 5-year-old learning how to count.
But the idea that pacemakers could just be essentially pasted on like some
Yeah.
boardwalk fare
Well,
is
I
pretty
mean,
exciting.
it
So,
is so cool. And if you can get it down to where you can implant it onto a little mouse heart, I have dissected mouse hearts. They are very tiny and delicate, and if you can achieve proper conduction across that tiny little surface, then oh man, it- having this in your heart and helping avoid an arrhythmia or defibrillating or something would be so much better, Josh, than the big bulky leads that we have now. I'm thinking of things like avoiding infection and inflammation that comes with the modern gadgets that we have nowadays.
moving on to our next story, equally impossible, or used to be, and now just improbable. What would you say, Santosh, is one of the least treatable conditions? Like, literally, when you find out you have it, that is the television style, you have X months to live.
As a pediatrician, the one that we are most scared of is an oncologic condition, which is diffuse infiltrating pontine glioma, which is a brain cancer, which you really can't get to, you can't treat well, and it's basically a death sentence. But in infectious diseases, uh, we can get to pretty much everything as long as there aren't too many complications and such. For many viral illnesses, still, we have zero cure. And it's not really a living infectious thing, but prion diseases, those we don't even know enough about them to like attack the problem. Like it's that scary that all right, you have this much time to live, and the diagnosis is a pain, and the treatment is there is none.
Prepare to be slightly less terrified.
Oh, okay, yeah. The cancer one or the prion one?
The prion one.
Oh, good. Yeah. Awesome.
So
I
an
would have loved
ex-
for you to have swooped in and, cured cancer too, but I'll take one.
I only have so many weeks free.
I'm sorry, too much pressure. I apologize.
An experimental therapy has dramatically extended the lives of mice that have been
Yay.
infected with prions, which is, of course, the same condition that causes Creutzfeldt-Jakob disease or mad cow disease for those of
CJD,
you
yeah.
of a certain age.
Yeah, yeah. So, bovine spongiform encephalopathy. I love saying that so much. But yeah, it's essentially misfolded proteins that cause the reason it's called spongiform is they cause holes in your brain, and eventually eat everything away, and you're left just completely debilitated. There are other ones out and about in the world, such as Kuru in Papua New Guinea, and Scrapie, I believe, is another one in some sheep. I think it was in Ireland.
So Sangamo Therapeutics have come up. Well, here's the background on their study. One of the things that makes prions or infection proteins
Hmm.
unusual
Yeah.
is that's exactly what you said, Santosh. They're not living. It's a misfolded protein that makes other proteins surrounding it misfold as well, and then join up to form these kind of damaged like fibrils and tangles.
Yeah, they get in they literally just take up space and incite inflammation, and it's basically
The Last of
the
Us.
yeah, exactly. It is the weirdest, just kind of wasting, scorched earth type disease. Like the prion doesn't get anything out of it, the host doesn't get anything out of it. It's just degradation. It's awful.
So, in almost every prion disease, the protein that misfolds is
Mhm.
one known as PRP,
Yeah.
cleverly named, prion protein. Uh,
Yeah, yeah. We have identified these. They're oftentimes, Josh, they are native proteins, so they're not invasive or anything like that. But almost like a genetic mutation, you get the wrong sequence of amino acids and stuff, and they just misfold and then induce this misfolding in
so, the
yeah.
normal function of this isn't entirely clear, but mice engineered without the ability to make PRP
Yeah.
are immune to prion diseases without any other apparent side effects.
Yeah.
And that's
It's
because there's no PRP to misfold, which seems to be the only target, or at least the main one.
Yeah, meaning that that's the most frustrating part. You would like to say that, like, oh, this is a necessary protein for, a metabolic process or a structure or something within a cell, but it doesn't seem to be. It seems like this protein can just F off. It's such a piece
So,
of shit.
so the researchers at Sangamo Therapeutics made a protein that binds to a specific sequence of DNA right near the gene that produces PRP,
Hmm.
and therefore blocks it. It never gets made, and therefore you are immune to prion diseases. So it's probably not going to do too much if you already have one, but a potential vaccine, or travel vaccine along the
Yeah.
way.
Okay.
Uh,
Yeah,
of
that could
course,
be.
of course, it will have to be delivered into the brain using viruses selected for their ability to target neurons. So,
Yes, yes. So you'd need to use a neurotropic virus. Herpes simplex is often a good one as a vehicle. Toxoplasma, actually, the little parasite that I study, is a good
Satosh,
one.
can
Yeah.
you imagine get herpes so your brain doesn't rot?
Yeah. There'd be a whole new group of herpetologists that would be.
Herpetologists.
Yeah, exactly.
um,
Yeah, yeah. It's
so,
yeah.
so to
Yeah, yeah.
to prove it's effective, the researchers infected mice with prions. Untreated mice got symptoms about 120 days later, and all were dead at 160 days. But if they were given a single dose of a virus carrying the gene for the impaired PRP protein.
Yeah.
And this would come 60 days into infection or 120 days later when the mice started to develop symptoms.
Sure.
A year later, so 360 days, a full 200 longer than the control mice, 10 of the mice were still alive out of 19. And
Oh, nice.
5 made it all the way to 500 days.
Oh,
So
hey, not bad.
we're not even talking a cure in mice. It is a long time away from being seen in a human sphere. But
Okay.
there is definitely a possibility that, one of the untreatable diseases may not remain so.
Gotcha. 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 Very cool. Oh, I'm glad the mice don't need prions. It's a story for another time, but it looks like, there are some upsides to prions in terms of evolutionarily, like the role that they play in things like long term memory and stuff like that. But for now, nuts to them all. And anything that we can do to squash them into oblivion, especially the misfolded ones, you guys, Sangano, way to go. You are doing the Lord's work.
So we'll follow along with that story to see how it develops. And let's take a moment here
Mhm.
to appreciate the fine folks who keep this podcast going. That's you and me, Santosh. Give ourselves a round of applause.
Yay! More Kermit arms.
and, and to keep doing so, we would love to be able to do more of our speaking engagements like comic book medicine or 80 plagues, or maybe there's something else you want to hear. So sign up with us at travelmedicinepodcast.com, and we'll even throw in a free 80 plagues book, which
Yeah,
you can share with all your friends without infecting computers.
you'll really love it. Honestly, it is well produced, and it's a lot of hard work from Dr. Josh. I will take credit for doing some edits and kind of shoring it up. But he illustrated it beautifully, and you can enjoy it on your electronic device, or you can print it out and have a beautiful hard copy as well.
Paper books, okay, boomer. So let's hear from a few of the sponsors who help to keep the lights on. And we're back. So back to Journal Club. Yay!
Yay!
And the next one, Santosh, we haven't done a full COVID episode in a while, and there's just enough research to make its own. But
Yeah.
I did want to at least touch on this story, which is something else that we didn't think possible, and I'm still not entirely sure is probable.
Okay, that's fair. In the world of COVID, you're talking about.
Yes, yes, and more
Okay.
specifically, the world of long COVID, which
Oh,
is what we're
yes.
getting a chance to study now, in the
Yeah.
post pandemic era. And one of diseases that can prevent or decrease the likelihood of long COVID are in short supply. And one of the new ones may be something that is very, very common to the point that I think even a lot of lay people would know it without having the condition. And that's metformin, used in the treatment of diabetes, type 2
Oh,
diabetes.
yes, absolutely. Okay. And it's not as well known in circles outside of pediatrics, but in adolescent medicine, I guess in actually adult medicine also, it is used to treat other diseases such as polycystic ovarian syndrome, because that comes along with some degree of insulin resistance, but it helps ameliorate a lot of the symptoms of PCOS as well. And I think it's found its way. Correct me if I'm wrong, into diseases like pre-diabetes as well, in order to actually like slow the kind of forward march to diabetes if you're on a bad path.
Now, before everybody runs out and starts clearing the shelves of this like it's toilet paper, I want to
Yeah.
emphasize
Yes.
we're talking about a research study, and they also said it really has only been shown to be effective, at least based on a lot of the population, in those who are already overweight or obese. And therefore, more statistically likely to already be on metformin for, as you said, Santosh, prediabetes or PCOS or some
or
of the other
diabetes.
conditions that can
Right.
affect your
Yeah, yeah.
your
We,
metabolism.
yeah, I don't think we want to go on the rant already to, all the folks who've been frankly depriving people of necessary drugs and using diabetic medication for cosmetic purposes by and large.
So
But anyway,
Carolyn Bramante at the University of Minnesota and et al.
yeah.
Who is this Al? No,
I don't
no.
know, man, but he's in everything. She, I don't know.
um, tested the potential of several different therapies, including metformin, and has been shown in a few smaller studies to limit the replication of SARS-CoV-2 in a laboratory setting. So they looked at 1,100 people between the ages of 30 to 85 who had tested positive for COVID within the past 3 days. Now, because we do see a lot of asymptomatic infections now, we don't necessarily know that they had only been positive for 3 days, but they had tested within so. They
Sure.
were, of those 1,100, they were all overweight or obese by BMI, which can raise the risk of severe COVID 19, but none of them required hospital care for this infection.
Got it. So they had mild enough disease that they didn't need to be on oxygen or receive steroids or, all these others. Okay.
They were then randomized into four different groups,
Mm.
including combat. Well, uh,
Well, it was actually 2 by 3, but yeah, it
yeah.
was lots of
So they
groups.
got combinations of metformin,
Uh-huh.
ivermectin, which by the time the study was done, we already know has no effect
Right.
whatsoever. So not entirely clear why that was chosen, but it's in there.
Well,
The
to be very fair, so this was between December of 2020 and January 28th of 2022. So this is while we were still examining ivermectin as a possible candidate for an antiviral.
along with the antidepressant medicine fluvoxamine or a placebo.
Gotcha. And they did try metformin plus placebo, ivermectin plus placebo, and then fluvoxamine plus placebo. So basically, they paired metformin with these three drugs, and then they gave those three drugs without the metformin on it.
Following up with everybody at 10 months, 6% of those who had taken metformin were diagnosed with long COVID, which sounds high until you compare to 10% on placebo,
Wow.
suggesting that the drug prevented, around 40% of long COVID cases,
Yeah.
assuming, again, same people in the groups, which is why you had the placebo. Neither ivermectin or fluvoxamine had any effect on the risk.
Yeah, the relative risk reduction over time was, not brilliant, but it was pretty good.
Well, I mean, a 40% decrease is pretty impressive, but
Yeah,
again, most of the study population was fully vaccinated, so already at a lower risk for getting long COVID. We don't know what else was going on in those 10 months, so there's a lot of potential confounds here that don't make this study invalidating, but could muddle the results a bit.
sure, sure. So I think it was a fair pilot. And overall, when the investigators took a look at the long COVID diagnoses of the folks who received metformin versus those who had a matched placebo, they actually saw that in terms of statistics, the two groups, metformin versus placebo, were almost the same in terms of their risk profile. And we had other issues going on in terms of, well, the younger folks, for instance, Josh, they did much better in this cohort than the older people over 45 years of age. And the variant, Alpha, Delta, or Omicron, did matter in terms of which ones caused more long COVID. So, but yeah, overall. Now, interestingly, Josh, when the medication metformin was paired with ivermectin or fluvoxamine, the the results weren't as good for those populations. It wasn't statistically significant, but actually ivermectin and fluvoxamine didn't help, and it may have even hindered the effect of the metformin.
You have brought the whole class down,
Yeah.
and
But
we
yeah,
are
it's we've got a beautiful candidate here for a protective medication, and it's also nice because it's ubiquitous, it's cheap, you know.
now. What's not clear is if it'll work on people who are not pre-diabetic or are not overweight or obese, because that literally was the entire test population.
That's true. Yes.
So it'll be a very interesting study to continue with. But let's move on to our last improbable
Yeah.
and now surprising story. And it is, you'll be happy to hear this, Santosh, another
Yay.
new antibiotic.
There's
Okay, we,
the
we laugh, listening
yeah.
audience, but they don't come gushing out the fire hose anymore. It's
No, that yeah, that's true. There's part of me that celebrates, especially if it has a novel approach to antibiosis, meaning that it doesn't necessarily, if it's the type of antibiotic that's not necessarily in its own, or sorry, it is not part of a previous class, meaning that, oh, okay, it's just, it's a cephalosporin, but it's something new, or a penicillin or something new. But there's another part of my brain, even as I celebrate an antibiotic, that goes, when are we going to get resistance to this one? It's very like Eeyore the old gray donkey.
say,
So,
okay,
yeah.
Eeyore. Well, if we head on down to the sandy soil of North Carolina
Oh, yeah. Yeah.
and scoop up some of that soil and then travel with it all the way over to Utrecht University in the Netherlands.
Uh, what are you doing right now? The soil part I got. Almost all of our antibiotics have come from bacteria or fungi in the soil.
Yeah, but it was US soil from the Netherlands.
Yeah.
So no, no. So researcher Marcus Weingarth
Yeah.
studied the soil and found that it killed a range of disease-causing bacteria,
Hmm.
including MRSA. That's practically admission at the door right there.
Yes.
You know,
That's
past.
VIP,
Mhm.
club kind of thing. That is the person who, like, the bouncer doesn't even need to check his list. In
And
you
the
go.
person who's hot and they knows it. Yeah, and the person who is hot and knows it.
Who is it?
Well, this bacteria not only can take on the MRSA superbug, but also tuberculosis.
Oh my god, this is like the VIP of the VIP. This is the hot celebrity that gets admitted through the side door, like not even through the front.
Although there are scientific paparazzi around going,
Yeah.
"Oh, how impressive," because we need to study this. And that's
Absolutely.
because most of our existing antibiotics target the cell wall around bacteria, which is, like a chicken wire kind of structure that surrounds the soft, squishy cell insides.
Yeah.
So if that is disrupted, everything rushes in and the cells pop. They burst open and die.
Yeah.
This is a great target because this cell wall isn't in our cells. So antibiotics will only kill bacteria.
Sure. Oh yeah. Yeah, that's if we don't have something that this chemical, this little molecule can attack, then it can't attack us. That doesn't mean it's side effect free. But it just means that, it won't destroy our cells outright.
No, usually the side effect is diarrhea. Like about
Yeah.
80% of the time.
Yeah, as we kill off the good bacteria in our gut along with trying to kill the culprit that's trying to kill us.
But most of these existing antibiotics usually target proteins that assemble the cell wall, and the bacteria, in an endless game of cat and mouse, will then
Yep.
just alter the shape of that individual enzyme to evade attack.
Right, right. So These are actually called, we have named them as penicillin binding proteins because these things that make the cell wall, penicillin binds to those and activates those so the cell wall can't be built.
So clovabactin, which is our new which is our new antibiotic, targets a group found on not just one, but three different components of cell walls. So to survive, a bacterium would have to alter all three, and the likelihood of being able to do that without making a fatal mistake
Yeah.
is going to be much, much harder to develop resistance. So cheer up, Santosh. It'll be a while.
That would be so good. So I I do want to give a bit of a shout out because we've mentioned this other antibiotic before. So this was kind of created imitating a previous discovery. So there was a development called iChip, and this provided access to a broad diversity of uncultured bacteria from the soil. And out of this, I think you remember, Josh, a while back, we talked about this brand new class of antibiotics. So the one that we discovered first was Teichobactin, the Teixobactin. And this one was isolated from LF. Sorry, let me pronounce this properly.
LMFAO
No, Eleftheria terrae.
is in the house
There.
tonight.
So again, it binds to these lipid precursors of the cell wall, and so you get these supramolecular structures, and that basically just sticks like a big plaque, and the membrane just becomes unstable and it falls down. So essentially, using this same kind of a technique, because Teichobactin was the kind of the parent compound. This one, clovibactin, is a cousin of this. And so far, Josh, I don't think we've seen Teichobactin, march its way down like phase 2 and phase 3 trials. But hopefully, this whole class of antimicrobials will start to emerge more and more, prove itself in human trials, and we'll be able to actually, get it.
And more things to make you feel good. The
Yeah.
team has already exposed bacteria to low doses of clovabactin, and
Okay.
that's an intentional choice,
Yeah.
folks at
This is
home.
in culture, right? In a petri dish. Huh?
Yeah, so in high bacteria culture, you give low doses of antibiotic to see if you can provoke resistance, and they got none. They said they tried very hard,
Hmm.
and what happens is when you have a low dose, bacteria are much more likely to quickly overcome the antibiotic and acquire resistance by outcompeting.
Hmm. Yeah.
Uh, Now, this will not treat any gram negative bacteria, and gram negative, again, counterintuitively, has an extra membrane outside the cell wall.
Yeah.
So they're negative because it does not pick up the stain that we use to detect bacteria.
Yeah, the staining that we use, and when you wash away or you counterstain, then they appear light pink rather than dark purple on your hematoxin and eosilin stain, gram stain. Sorry.
So in field mice testing,
Yeah, exactly. Okay.
no adverse effects. So
Ooh.
Novobiotic Pharmaceuticals is now developing it further towards humans. But in a wonderful parting shot from the scientist in charge,
Sure.
researcher Weingarth, he says it's a very, very long way from mice to humans. I repeat, I do not want to oversell this.
I think that is a very responsible thing to say. As we said, just to give everybody a kind of peek behind the curtain of how research and development goes, Teichobactin was discovered, between four institutions in the US and Germany who used this isolation chip, found this hard to culture bacteria, Eleftheria terrae, and found this antibiotic chemical, Teichobactin, tested it, looked at it beautifully, but we're still waiting for it to advance through, you know, animal and human trials and everything else like that. So these things do not move quickly, folks.
That's what I'm going to name the episode, Santosh. Journal
Hmm.
Club. I don't want to oversell this.
Yeah. That'll get people to click on it.
I don't know. Did it work? Did you like? Would you like to have more of these kinds of journals answered? Did we oversell this? Reach out and contact us at
You mean
travelmedicinepodcast.com.
you don't want to brand this as this may cure every illness ever? More at
No,
7.
that would be Journal Club. I definitely want to oversell this.
I don't know. I love nuance and I'm glad that we're nuanced, but I don't do the clickbaity things work? You let us know. Or do you guys want us to stay nuanced?
Subtlety. It's what we're known for.
Yeah.
So that's it for this week. As always, we love to hear your comments, questions, and feedback. If you'd like to support us spiritually, emotionally, or financially, links to do that are in the show notes, or by signing up for our mailing list about future appearances, shindigs, and get togethers on Discord or otherwise.
I fully understand if nobody wants to make the get-togethers, but you do not want to miss the shindigs. I'm just
Or the ice cream socials. Can't back that up. Nope.
not promise ice cream every time.
More people will come if you tell them to be punching pie.
Yeah.
Our-
It's gonna be all right, audience. I want everyone out there who's old enough to remember Punch and Pie
Our
to
theme music.
please let us know that we're not that old.
Our theme music is composed by Rachel Leisure. This show is produced by me with a lot of help from Dr. Santosh and friends. And until next time, as always, keep a song in your heart, soap on your hands, a shot in your arm, spin a globe, find a place that's open and looks interesting. And when you've done all of those things, happy travels.
Oh my god, you guys.